So, hello student, very good morning to everyone. So, these are the points that we had learned in the last lecture. That is carbon-carbon bond formation in aromatic compounds. So, in 1934, the in 1934, uh, he is the name of scientist who reported that the thermal decomposition of diazinon salt in aromatic solvent result in the annihilation of aromatic rings, and he explained this result by following mechanism involving the direct displacement of hydrogen atom in the aromatic solvent molecule by aryl radical, the abstraction of entire aryl group of the solvent molecule by aryl radical. So he first reported that the thermal decomposition of diazinon salt in aromatic solvent result in the annihilation of aromatic rings. So when this diazinon salt treated with aromatic solvent of HB, you will get the annihilation of the ring, and this is the general reaction mechanism. This diazinon salt undergoes homolysis. It generates Ar radical N2 molecule and X radical. Then in the next step, this Ar radical react with your solvent, aromatic solvent. You will get the annihilation of the rings, and this X is nothing but the chlorine acetate or hydroxy group. Now a similar result are also obtained from the aryl radical generated from the other source, such as decomposition of benzoyl peroxide in aromatic solvent. So the same result also obtained, that is annihilation of the ring, when when the decomposition of benzoyl peroxide takes place in aromatic solvent. So this is your benzoyl peroxide. This benzoyl peroxide gives annihilation in presence of aromatic solvent. So it having this peroxide bond. So you know that this peroxide bond is a weak bond, so it will breaks here. Okay, like this it will. Let me show you that. Okay, it will, this peroxide bond will breaks homolytically. You will get the benzyl oxy radical. You will get the benzyl oxy radical. Okay, then this benzyl oxy radical undergoes decarboxylation. Okay, you will get two pH radical and CO2. So in this way the decarboxylation reaction takes place, and you will get your pH radical. Then this pH radical react with your aromatic solvent, that is benzene, and the annihilation of the ring takes place. So this is a simple reaction and its mechanism. So decarboxylation of this benzyl peroxide in presence of aromatic solvent gives the annihilation of the ring. And so again, in the last lecture we had learned the reactivity in aromatic substrate. So free radical substitution at an aromatic carbon takes place by mechanism in which a ring hydrogen is abstracted to give aryl radical. So free radical substitution at an aromatic carbon takes place by mechanism in which the ring hydrogen is abstracted to give aryl radical. Usually the mechanism is similar to aromatic electrophilic and nucleophilic substitution reaction. So there are some generalization has been made on the reactivity of aromatic substrate. So all the substrate increases the reactivity of ortho and para position as compared to that of benzene. There is no great difference between electron donating and electron withdrawing groups. This is because the radical are neutral species and are not influenced by the polar properties of the substrate and any significant extent. Furthermore, it has been shown that electron donating electron withdrawing group stabilize the free radical. So this what we had learned in the last lecture. Again, in the last lecture we had learned the Hunt-Dicker reaction. So this is the mechanism of that. This is the reaction and the mechanism of Hunt-Dicker reaction. So this, what is the Hunt-Dicker reaction? So reaction of silver salt of carboxylic acid. The reaction of what? Silver salt of carboxylic acid in presence of Br2 and CCl4 to give alkyl halide or aryl halide. To give alkyl halide or aryl halide is called as Hunt-Dicker reaction. It's called as Hunt-Dicker reaction. The reaction of silver salt of carboxylic acid with bromine leading to alkyl or aryl radical aryl halide is called as Hunts-Dicker reaction, and it is the way of degrading the carbon chain by one unit. Although bromine is often used halogen, and instead of bromine, chlorine and iodine also have been used. So this your silver salt of carboxylic acid when treated with Br2 in presence of CCl4, you will get this vinyl bromide. You will get this vinyl bromide, and its mechanism is very simple. This silver salt of carboxylic acid, you are reacting with Br2, okay. So this O minus oxygen anion attack on this Br, okay, because this Br2 is a polar molecule. There is a positive charge on one Br and there is a negative charge on another Br. So this O minus attack on this Br, and this, okay, so this oxygen will form bond with this Br, so you will get this OBr, and this Br minus form ionic bond. It form ionic bond with silver. It form what? Ionic bond with silver. Okay, you will get this AgBr. AgBr. Now in the next step, the homolysis of this OBr bond takes place. Homolysis of this OBr bond takes place. You will get O radical, then this O radical undergoes, so this, now you will get this carboxyl radical. So this carboxyl radical undergoes decarboxylation. It undergoes decarboxylation reaction. So the decarboxylation means simply the loss of CO2. So this radical will delocalize here. Same way the breaking of this CC bond takes place, it generates CH2 radical, and this CO radical delocalizes, it form carbon oxygen double bond, and you will get CO2 as a product. You get what? CO2 as a byproduct. So here plus plus, it is a plus sign, CO2 decarboxylation. Okay, so plus CO2. Then the next step is this vinyl radical react with this Br radical generated in the steps 2, which is generated in a steps 2, and simply you will get this vinyl compound, vinyl bromide. So this is the simple reaction and mechanism of Hunts-Dicker reaction, and the reaction of silver salt of carboxylic acid with bromine leading to alkyl halide or aryl halide, that is called as Hunts-Dicker reaction. So this is just a revision that what we had learned in the last stage. Okay, now let's move towards the next slide. So move towards the next slide. So students, today I am going to teach you the Pinacol coupling reaction. Which reaction? Pinacol coupling reaction. Today I am going to teach you Pinacol coupling reaction. Okay. So first we'll see the definition of Pinacol coupling reaction. So this reaction involves the reductive homocoupling of carbonyl compound to produce symmetrically substituted 1,2-diol. Okay, so Pinacol coupling reaction means this reaction involves the reductive coupling, homocoupling of carbonyl compound to produce symmetrically substituted 1,2-diol. That reaction is called as Pinacol coupling. So this is the general reaction. So this is your carbonyl compound. Okay, when this carbonyl compound treated with magnesium in presence of H plus and water, you will get this 1,2-diol. This reaction is called as homocoupling reaction. Okay, so this is your 1,2-diol. Okay, so which of your alcohol OH group present on this 1 and 2 carbon, that is a 1,2-diol. Okay, 2 OH group, it's a diol. So this is the reaction mechanism. Following is the mechanism of Pinacol coupling reaction. So this is the simple mechanism, general mechanism of this reaction. So okay, so in the first step, in the mechanism open, in the first step, the single electron transfer of the carbonyl bond which generate radical ion intermediate, and that couple via carbon carbon bond formation to give 1,2-diol. And okay, so this is the simple mechanism. So your magnesium, in the last cell of magnesium, you are having 2 electron. Okay, so it oxidizes itself. Okay, that undergoes oxidation, it will give its electron. Okay, so you are using two carbonyl uh, compound. Okay, starting material two ketones. Consider this is your ketone. Okay, RR. So this is the general formula for ketone. So this magnesium give its electron. Okay, so that electron will attack on this carbon. Okay, the bond will break, negative charge on oxygen, and you will get the radical ion. What you will get? Radical ion. Radical also and ion also. Oxygen ion and radical on this carbon. Okay, so same way this your magnesium reduce another ketone. Okay, and you will get the two radical anion of this ketone. Okay, so in this way you will get this, and this magnesium will form covalent bond with this oxygen anion. Oxygen have negative charge, so now this after losing electron. Okay, so there is a positive charge on your magnesium because it loses its one two electron. Okay, so this is your radical anion. Radical anion, that's what is called as radical anion. Now in the next step, this radical anion undergoes homocoupling. Okay, homocoupling. So this two radical will couple together, you will get this compound. Okay, then the next step is simply what uh, your in workup you are adding this acid. So so simply what this your oxygen anion takes proton from the solvent. This O minus takes proton from the solvent, convert to OH. So this is the simple reaction mechanism. This is the simple reaction mechanism of your what Pinnacle Pinnacle coupling reaction. Pinnacle, because it's a Pinnacle coupling reaction. Okay, so uh, Pinnacle coupling reaction. This reaction involves the reductive homocoupling of carbonyl compound to produce symmetrically substituted 1,2 diol. Okay, so this is the reaction. So this carbonyl compound when treated with magnesium in presence of H plus and water. Okay, you will get this 1,2 diol, symmetrically substituted 1,2 diol, and this is the following is the mechanism of Pinnacle coupling, general mechanism. So this is ketone. Okay, general formula for ketone around reaction with magnesium metal. Okay, so this magnesium having two electron in its last shell. It having how many electron? Two electrons. Okay, so this magnesium undergoes oxidation. It loses its electron, and this will reduce this molecule. Okay, so that electron will attack on this carbon. Okay, and the bond will break, negative charge on oxygen, and generate radical anion. Okay, same way this magnesium reduces another ketone molecule, and you will get this radical anion. Okay, now both the ketone convert into radical anion. Okay, so this is a radical anion, radical anion. Now the next step is now when this, so your magnesium form covalent bond with this. Okay, then the simply the homo coupling of these two radical anion, and you will get this compound. Then simply work up. Okay, this oxygen anion takes this hydrogen takes this proton and convert to 1,2 diol, convert to 1,2 diol. So this is the simple reaction mechanism. This is what simple reaction mechanism of Pinnacle coupling reaction. Pinnacle coupling reaction, Pinnacle coupling reaction. It is nothing but the reaction. This reaction involves what? Reductive homocoupling of carbonyl compound. It involves reductive homocoupling of carbonyl compound to produce symmetrically substituted 1,2 diol. To produce symmetrically substituted 1,2 diol, that reaction is called as Pinnacle coupling reaction. Now let's move toward the next slide. So here in this slide, this is the application of your Pinnacle coupling reaction. Okay, so this is your benzophenone. Benzophenone, two molecules of benzophenone. We are taking the two molecules of benzophenone. Okay, these two molecules of benzophenone on reaction with magnesium metal in presence of water and acid. Okay, so you will get this 1,2 diol. You will get this 1,2 diol, and the reaction mechanism is following the reaction mechanism for this Pinnacle coupling reaction. So what happened in this reaction? You are using benzophenone. Okay, you are using what? Benzophenone. So it reacts with your magnesium metal. It react with your magnesium metal, and your in the last shell of magnesium metal you are having two electrons. You are having two electrons. So that magnesium metal undergoes oxidation reaction. It undergoes what? Oxidation. It loses its electron. It loses its electron, and it reduces your this benzophenone. It reduces benzophenone. phenol. Okay, it reduces benzophenol. So magnesium having two electrons, so same way this you are using two benzophenol, so both the benzophenol molecule will reduce. Okay, and you will get two radical anion of benzophenol. You will get two radical ion of benzophenol. So these are the two radical anion benzophenol, and oxygen having negative charge. So this oxygen form covalent bond with your magnesium metal Mg+2, and this is your radical and ion. Then the next step is next step is simply what the coupling of these two radical ion is coupled together, and you will get this compound. Then the next step is this your this coupled molecule. Okay, in on reaction with what you're treating acid with this compound. Okay, so simply this oxygen anion, okay, it takes this proton, convert to 1,2 diol, it convert to 1,2 diol. So this is the simple reaction mechanism of this Pinacol coupling reaction, of this what Pinacol coupling reaction. So here this I am again explaining this what your benzophenol, two molecules of benzophenol, you are using two molecules of benzophenol, it react with magnesium metal, it react with what magnesium metal in presence of small amount of acid and water, and you will get you will get your 1,2 diol, you will get what your 1,2 diol, and this is the reaction mechanism of your Pinacol coupling reaction. Pinacol coupling reaction. So this is the this is not a reaction Pinacol. This is the what a reaction mechanism of Pinacol coupling reaction. So this benzophenol on reaction with magnesium metal. This is on what your reaction with magnesium metal. So you are using magnesium metal, and this magnesium metal undergoes oxidation, it loses its electron and it reduces this benzophenol, and so this bond will break. You know, this having what carbon oxygen double bond, one pi bond and one sigma bond, so the pi bond will break and the bond pair shift on oxygen, so you will get radical anion. So you will get what radical ion, it's not an ion, you will get radical ion. Now this radical ion, okay, so you will get two radical ion of benzophenol, you will get two what radical ion of benzophenol. Then this two radical ion of benzophenol undergoes coupling. Okay, it undergoes what coupling. So the coupling or reaction between these two molecule takes place, this molecule coupled together, and you will get this your coupled product. Then this coupled product on treatment with acid, this oxygen and ion, both the oxygen and ion take this proton, okay, and convert to OH. So this is the simple reaction mechanism. Okay, so this is the application of the Pinacol coupling reaction. Now let's see the another what your another reaction of Pinacol coupling reaction. Okay, another application of Pinacol coupling reaction. So yeah, now this is acetone, two molecules of acetone when react with magnesium and presence of water and acid, okay, H plus, you will get this 1,2 diol. Okay, so this is your now your Pinacol. Okay, this is your now Pinacol. Okay, so the example depicted, okay, this example given is show the preparation of Pinacol itself. Okay, it shows the preparation of Pinacol itself. The example shown here, it show the preparation of Pinacol itself. So it can be prepared by two molecules of acetone in presence of magnesium metal, water and acid, and you will get this Pinacol. Okay, and now let's see its reaction mechanism. Let's see what reaction mechanism. And reaction mechanism is very simple. Reaction mechanism is very simple. Your acetone, two molecules of acetone, it these two molecules of acetone react with your magnesium metal, it react with your magnesium metal. Okay, so you know the magnesium having two electron in its large shell, so it will undergoes oxidation. Okay, so this magnesium metal undergoes oxidation, and this will what it will reduce this carbonyl, this acetone. Okay, and you will get this radical anion. So when the electron attack on this carbonyl carbon, the bond will break, the bond pair shift on oxygen, so there is a negative charge on oxygen and a radical on this carbon. Okay, when it gives electron, it generates radical and anion, that's why it is called as radical ion. Then this oxygen, both the oxygen and ion form covalent bond with magnesium metal, okay, Mg+2. Then these two radical coupled together, you will get this product, okay. Then the next step is this oxygen anion takes takes proton from solvent, convert to Pinacol. So this is your what? Pinacol. This is your what? Pinacol. Pinacol. ठीक है. So the preparation of Pinacol start with your acetone, 2 molecules of acetone, okay, 2 molecules of acetone in presence of magnesium metal, in presence of what? Magnesium metal and water and acid, you will get this Pinacol. And this is a simple reaction mechanism, okay. So in the reaction mechanism, magnesium metal undergoes what? Oxidation, it reduces this molecule, you will get this radical anion, and then the radical anion, okay, coupled together, you will get this product. Then simply the oxygen anion takes proton and you will get this 1,2 diol, okay. So the first step is single electron transfer of the carbonyl bond, which generate radical ion intermediates. This is your radical ion intermediate. What is the name of this? This is your intermediate, and the name of this intermediate is the radical ion intermediate, okay. And both this radical ion coupled via carbon-carbon bond formation to give 1,2 diol. So this is the preparation of your Pinacol and its reaction mechanism. Preparation of Pinacol and its reaction mechanism. Now let's move towards the next slide. Okay. Now the next reaction I am going to teach you, that is Mach-Murry coupling reaction. Which reaction? Mach-Murry coupling reaction. So Mach-Murry is the name of scientist who discovered this reaction. That's why that this reaction is called as Mach-Murry coupling reaction. Mach-Murry coupling reaction. So this reaction is similar to what your Pinacol coupling, similar to Pinacol coupling reaction. Okay. So what is the Mach-Murry coupling reaction? So the reaction of carbonyl compound in presence of titanium third, titanium trichloride with potassium or lithium metal to produce alkene as a product is called as Mach-Murry coupling. Is called as what? Mach-Murry coupling. The reaction of carbonyl compound in presence of titanium trichloride with potassium or lithium metal to produce alkene as a product is called as Mach-Murry coupling reaction. What? Mach-Murry coupling reaction. So Mach-Murry coupling reaction means the reaction of carbonyl compound in presence of titanium trichloride with potassium or lithium metal to produce alkene as a product. That reaction is called as Mach-Murry coupling reaction. This is the general reaction of Mach-Murry coupling reaction, okay. So this your carbonyl compound, 2 molecules of carbonyl compound react with titanium trichloride in presence of potassium metal, THF solvent reflux, and you will get this alkene as a product. Then the following is the mechanism of Mach-Murry coupling reaction, general mechanism of Mach-Murry coupling reaction, okay. So this is your what your this as your ketone on reaction with potassium or lithium metal, okay, potassium or lithium metal. So or 2 electron, or a 2 electron, you can write here potassium or lithium metal, okay. So you are using 2 molecules of this your carbonyl compound, so it reduces both the molecules, that's why, and it requires 2 electron for reduction, that's why we are writing 2 electron. So this potassium and lithium, okay, both having what it having 1 electron on its large chain, okay. So here consider potassium metal. So potassium metal, it oxidizes, okay, it will give its electron, and that electron will attack on this carbon of your carbonyl compound, okay. It attack on the carbonyl compound, so the bond will break, okay. This bond will break. Let me show you that. consider this electron attack on this. Okay, carbon carbon bond will break, negative charge on oxygen, and you will get this radical anion. Okay, same way the another potassium or another potassium attack on the another carbonyl compound. Okay, so it it reduces another molecule of your carbonyl compound, and you will get this radical anion. This O minus is with your potassium plus. Okay, so this is your radical anion. This is the intermediate form in the Mach-Murry coupling reaction. Okay, radical ion. So two radical ion. Then the next step is the coupling of these two radical ion. Okay, like this. What the coupling of this radical ion? Homo coupling, and you will get this coupled product. Then the next step is what? The next step is simply this oxygen. Your what? This oxygen anion takes hydrogen from solvent. So here hydrogen is there, H plus, H plus. Okay. So this is your proton, hydrogen plus. So this oxygen anion takes this hydrogen, convert to H. Same this oxygen anion takes proton. Okay, convert to OH. Now the next step is simply, let's say, dehydration reaction. Say dehydration reaction. It's a dehydration reaction. So loss of two water molecule, and you will get this alkene. So the difference between your Pinacol coupling and Mach-Murry coupling is that what in both the reaction, what you will get this 1,2 diol, and but your Mach-Murry coupling is the extension of your what Pinacol coupling. Okay, so whatever the diol you get, that undergoes dehydration, and you will get your alkene as a product. You will get your alkene as a product. So both this water, this OH, okay, and hydrogen from this carbon, and this OH undergoes dehydration twice H2O, and you will get your alkene. So this is the simple reaction mechanism, general reaction mechanism of your Mach-Murry coupling reaction. Which reaction? Mach-Murry coupling reaction. So Mach-Murry coupling reaction means the reaction of carbonyl compound in presence of titanium trichloride with potassium or lithium metal to produce alkene as a product. That reaction is called as Mach-Murry coupling reaction. So this is carbonyl compound, two molecules of carbonyl compound when react with titanium trichloride in presence of potassium metal, CHNFN reflux. Yeah. So this is not a relux, it's a reflux. F is there. Okay. Yeah, F. The reflux, and you will get this alkene as a product. Okay. This reaction is called as Mach-Murry coupling reaction. Okay. And this is the general mechanism of Mach-Murry coupling reaction. General mechanism of what? Mach-Murry coupling reaction. So yeah, in mechanism what happen? This your carbonyl compound react with your potassium or lithium metal. Okay, so this potassium or lithium metal having one electron in its large shell. Okay, that potassium metal undergoes oxidation, it loses its electron. Okay, that electron attack on this your carbonyl carbon of your, consider this your ketone. Okay, so it will attack on this carbonyl carbon, and the bond will break. That is pi bond. You know that the pi bond is a weak bond, so it easily break, and the bond pair shift on oxygen, so there is a negative charge, and it generates radical on this carbon, and this is called as radical ion. This is called as what? Radical ion. You will get two radical ion. Then the next step is the coupling of these two radical ion takes place like this. like in your Pinnacle coupling, the coupling of these two radical ion takes place. So you will get this coupled product. You will get this coupled product. You will get this coupled product. Now next step is this oxygen anion takes takes proton from solvent. This is your H plus. Okay. So both this oxygen anion takes proton from your solvent convert to H. Now you will get this 1,2 diol. You will get this what? 1,2 diol. 1,2 diol. Now the next step is once you get this 1,2 diol, it undergoes your what? It undergoes it undergoes dehydration. It undergoes what? Dehydration reaction, loss of water molecule, and you will get this alkene as a product. You will get this alkene as a product. So this is a simple reaction and the mechanism of Mach-Murry coupling reaction. Simple reaction and general reaction mechanism of Mach-Murry coupling reaction. So this the reaction of carbonyl compound in presence of titanium trichloride with potassium or lithium metal to produce alkene as a product. That reaction is called as Mach-Murry coupling reaction. Reaction of carbonyl compound with titanium trichloride in presence of potassium or lithium metal, potassium or lithium metal, Li. So this is lithium L, potassium or lithium metal to produce alkene. To produce this alkene, to produce this what? Alkene. Okay, this reaction is called as Mach-Murry coupling reaction. Now let's move toward the next slide. Okay, so application of this Mach-Murry coupling reaction. We'll see the application of this Mach-Murry coupling reaction. Okay, so this is your acetone. We are taking the two molecules of acetone in place of TiCl3, titanium trichloride, in place of potassium metal THF tetrahydrofuran, and reflux. It's a reflux. Okay, MAU say reflux, REFLUX reflux, and you will get this alkene as a product. You will get this what? Alkene as a product. This is the example of your Mach-Murry coupling reaction, and the following is the mechanism of your Mach-Murry coupling reaction. Okay, so your acetone, two molecules of acetone, it react with your lithium or potassium metal. So you know that this potassium or lithium metal having one electron in its last shell. It having one electron in its last shell. Okay, so having one electron in its last shell. So this potassium or lithium metal undergoes your oxidation. It undergoes oxidation. Okay, it undergoes oxidation. So it loses electron. Potassium or lithium loses electron, and that electron attack on the carbonyl carbon of this acetone, and the bond will break. That is your pi bond. Bond will break. That is the pi bond, and the bond pair shift on oxygen. The bond pair what? Bond pair shift on oxygen. So there is a negative charge on oxygen, and it generates radical ion. It generates what? Radical ion. So role of this potassium and lithium metal is that uh, it oxidizes itself and it reduces this your carbonyl compound. Okay, so by giving its electron, so this potassium and lithium having one electron. Okay, so here the potassium metal it loses its electron by oxidation, and that electron will attack on this carbonyl carbon of this acetone. The bond will break, and the negative charge shift on oxygen. Okay, and you will get this radical ion. Okay, same way the another molecule of this acetone undergoes reduction and you will get this radical ion. Two molecules of radical anion. Two molecules of this radical anion. Okay. Now this radical anion undergoes homocoupling. It undergoes what? Homocoupling. Coupling of these two radical anion, and you will get this coupled product. You will get this what? Coupled product. Then the next step is once you get this coupled product, this coupled product treated with acid H plus. So this you are having oxygen anion O minus. This oxygen anion takes this hydrogen. It will take this hydrogen like this. Okay, it will take this hydrogen and convert to OH. Same way you are having this another oxygen ion, so it will take this proton and convert to OH. So we will get this 1,2 diol. You will get this what? 1,2 diol. The OH group on carbon number first and carbon number 2. Okay, so it's a 1,2 diol. 1,2 diol. 2 OH group. That's what is called as 1,2 diol. Now the next step is simply hydrolysis. Next step is what? Simply hydrolysis reaction. Sorry, it's not a hydrolysis, it's a dehydration reaction. It's what? Dehydration reaction. You know what is my dehydration reaction? Dehydration reaction means loss of water molecule. Loss of water molecule. So now you are having two OH groups. So both this OH group and the one hydrogen on this carbon and one hydrogen on this carbon undergoes dehydration reaction. It undergoes dehydration reaction and you will get this alkene as a product. You will get this alkene as a product. So this is the simple reaction, that is this acetone, how this acetone undergoes Mach-Murry coupling reaction in presence of TiCl3, that is titanium trichloride and potassium metal, and the solvent is tetrahydroxyuron and reflux. You will get this alkene as a product, and this reaction is called as Mach-Murry coupling reaction. This reaction is called as what? Mach-Murry coupling reaction. So following is the mechanism of Mach-Murry coupling reaction. So this acetone, okay, acetone on reaction with potassium or lithium metal. Acetone on reaction with potassium or lithium metal. So the role of this potassium is that it reduces your carbonyl compound. It reduces your what? Carbonyl compound. So it loses its one electron, okay, and that electron attack on this carbonyl carbon and the bond will break. That is pi bond, and the bond pair shift on oxygen. Bond pair shift on oxygen. So there is a negative charge on oxygen, and you will get this radical anion. You will get what? Radical ion. Then this radical ion undergoes coupling reaction. Radical ion undergoes coupling reaction. You will get this 1,2 diol. Radical ion undergoes coupling reaction. You will get this coupled product. And the next step is this oxygen anion. Oxygen ion takes hydrogen, takes proton from solvent, convert to 1,2 diol. Now it's convert to 1,2 diol. It convert to 1,2 diol, and once you get this 1,2 diol, the dehydration reaction takes place. Which reaction takes place? Dehydration reaction takes place. Dehydration reaction takes place. Dehydration reaction takes place, and you will get this alkene as a product. You will get this alkene as a product. So this is the simple reaction. Now let's move towards the next slide. Let's move towards the what? Next slide. So this is another application of your Mach-Murry coupling reaction. This benzophenone on reaction with titanium trichloride in presence of potassium metal, and solvent is THF, and when you reflux this, you will get this alkene as a product. This reaction is called as Mach-Murry coupling reaction. This reaction is called as what? Mach-Murry coupling reaction. Mach-Murry coupling reaction. So this is the mechanism of Mach-Murry coupling reaction. This benzophenone reaction with potassium or lithium metal. So the role of this potassium metal is that it oxidizes itself and it reduces benzophenone. So it having one electron in its last shell. So that one electron, it loses its one electron and it reduces this carbonyl compound, okay, and the bond will break. The negative charge on the bond pair shift on oxygen. So there is a negative charge on oxygen, and you will get this radical ion. You will get this what? Radical ion. Once you get this radical ion, this you are getting two radical ions. So here two, okay, same here in this first example, two. So you will get this radical ion. Then this coupling of this two radical ion takes place. Okay, it undergoes coupling, Homo coupling, and you will get this product, coupled product. You will get this what? Coupled product. Now once you get this coupled product, okay, you are having negative charge on both the oxygen. That oxygen takes proton from solvent. This oxygen takes what? Proton from solvent. It takes oxygen from hydrogen from proton. Sorry, it takes your this oxygen ion takes proton from solvent and convert to OH. Convert to OH. So you'll get this 1,2 diol. You get this what? 1,2 diol. And once you get this 1,2 diol, so simply dehydration reaction takes place. Which reaction? Dehydration reaction takes place. Dehydration means loss of water molecule. Dehydration reaction takes place, loss of water molecule, and you will get your final product, that is alkene, the compound having carbon-carbon double bond. So this is the simple reaction. This benzophenone undergoes McMurry coupling reaction. Two molecules of benzophenone in place of TiCl3, titanium trichloride, potassium metal. This reaction is called as McMurry coupling reaction, and you will get this alkene as a product in McMurry coupling reaction. And this is the mechanism of McMurry coupling reaction. What mechanism of coupling? McMurry coupling reaction mechanism is very simple. This benzophenone undergoes reaction with potassium or lithium metal. Reduction of this carbonyl compound takes place, and it generates a radical ion. The radical ion to radical ion. That these two radical ion undergoes coupling, okay, and you will get this couple product. Then the next step is this, you are having in couple product, you are having oxygen ion. This oxygen ion takes proton from solvent, okay, convert to OH. You will get this OH. Okay, you will get this OH. And the next step is, once you get this OH, that is 1,2 diol, you will get this 1,2 diol. Once you get this 1,2 diol, the next step is dehydration reaction takes place. Dehydration reaction takes place, that is loss of water molecule, two water molecule, okay, one hydrogen from this carbon, one hydrogen from this carbon, and this OH, okay, loss of two water molecule, and you will get this final product alkene. Okay, now thank you.